unit, we have the following 3 problems. So the first problem is, what combination of goods to consume? So in this problem, what we have is the quantity of some product, I'll call it product Y, on the vertical axis, and we have a quantity of some other product, product X, on the x-axis. The second problem is how many hours to work and therefore not work. So how many hours to spend in leisure or free time, and how much to consume. So in this problem, what we are comparing are 2 consumption goods, the one being free time. So free time is something that when we consume, we get utility from it. On this axis, we have all other consumption. So everything except for free time. Okay. Now, in order to solve this problem, we're going to look at a different type of budget constraints. So in both of these examples, our feasible frontier is identified by a budget line. So in both of these examples, we have a straight line, which is our budget line or budget constraints. In this problem with free time and consumption, we say that the maximum amount of free time that you can consume is 24 hours a day. And the minimum we usually set at 8. Okay, so you can only at most spend all hours of the day in free time, but at minimum you can spend 8. That's basically sleeping, resting. We then have on this axis the maximum consumption that you can receive. And because you are having to rest for at least 8 hours a day, it means that the maximum amounts of work is going to be 16 hours. And so your maximum consumption will be 16 times your wage rate. So at most, you can work 16 hours a day. You'll be paid some wage rate per hour, and that is the most that you can consume with. Okay. In this example here, we tell you that you have some budget, some income, and you have to divide this income between these 2 goods. If you consume all of your income on X, it means that you can buy however much you have as income divided by the price of X. On the other hand, if you spend all your income on Y, then the most that you can afford to buy is whatever your income is divided by the price of Y. We call these 2 values here real income in terms of Y or X. So it's what your income is worth in terms of units of a given product. So these intercepts are slightly different, but we end up with the same sort of shaped feasible frontier. So both of these budget lines are a feasible frontier because what it tells us is that everything on that budget line and inside the budget line is a feasible consumption. The same thing with this budget line here. Every point on the budget line and every point inside the budget line is a feasible combination of consumption and free time. So you could be anywhere inside or on the budget line. Same thing here, anywhere inside or on the budget line. The final problem that we look at in this unit is a problem in which the individual is both the producer and the consumer of something. Okay, so think about the example they use in the book. You as a student produce grades. You produce a certain mark in a course. How do you produce that mark? You produce that mark by spending your time studying. So we have a production function, right? So we have the grade or the mark we get in the subject, and we have the amount of time we study. The more we study, the higher our grade, but it is increasing at a decreasing rate. So we say that there is diminishing marginal product of hours of study. If we take this production function and instead of plotting the grade against hours of study, we plot the grade against free time. In other words, hours not spent studying. Then we end up with a feasible frontier that is simply the mirror. So if you take this and you flip it around, you get this shape here. So this is a feasible frontier that is the inverse of the production function. And exactly like these two feasible frontiers, this represents all possible combinations of free time and marks that you could achieve. So what the feasible frontier tells us, so feasible frontiers tell us what is possible. So they give us what is possible. What is possible is only one side of choice. So everything in Unit 2 is about choice. How do we choose to consume two things in certain combinations? And choice depends on what is possible, so what is feasible, and it depends on what is preferred, so what is best. When we look at what is possible, we're dealing with feasible frontiers. When we look at what is preferred, we're looking at indifference curves. So in all of these models, we can see what is feasible. We then add in our indifference curves. And then when we bring these two things together, we find the optimal choice or the equilibrium choice, the best response of this person. Okay, so I'm setting this up to show you that the theory carries through all of these models. And the crux of these models is identifying the optimal choice where MRS equals MRT. And we're going to go through these two things in the examples I'm going to do. Okay, so that was like an 8-minute summary of Unit 3, or just the main points of Unit 3. Is everyone happy with that as a start? Okay, so I'm just trying to set the tone before we jump into the questions. Are there any questions up until this point? Anything that I need to clarify before we go into the past paper questions? Okay, so I don't see any questions in the chat, but if you are busy typing something, so if you are typing something, by all means, throw it into the chat and then I'll pause and answer the question. Okay, but let's go into question 1. So question 1 tells us that Alyssa receives an income of 196 rands. So this is her income, which she can spend on popcorn and lollipops. So these are the two products. The price of a bag of popcorn is 14 rand and the price of a lollipop is 4 rand. Assume that Alyssa spends her full income on these two products. So what this means is that she is definitely going to end up somewhere on her budget line. So every point on this budget line represents spending all of your budget. If you end up inside your budget line, it means you aren't spending all of your budget. So you're not maximizing the utility that you can derive from consumption. It asks us then to write down an equation for Alyssa's budget line if popcorn is shown on the x-axis. So what we want is a line that, if we had to plot it, it would have some intercept in terms of lollipops and a slope. And the slope of this budget line, and it's going to look really similar to Unit 2, the slope of this budget line is going to be the relative price of popcorn. So the relative price of the product that is on the x-axis. So just like with the isocost line in Unit 2, I like to present this equation by first explaining it in terms of everything that you have to spend gets spent. So income is going to be equal to the price of popcorn times the quantity of popcorn plus the price of a lollipop times the quantity of lollipops. This equation defines the budget line. So this is saying everything she has, she spends. So this is spending on popcorn, and this is spending on lollipops. Now I'm just going to sub in the values. So 196 is equal to 14 quantity of popcorn plus 4 times the quantity of lollipops. And because I want lollipops as my dependent variable, I'm going to rearrange this so that QL is on its own on the left-hand side. So I'm going to have 4QL is equal to 196 minus 14QP. And then I divide through by 4. So I get the quantity of lollipops is equal to 196 over 4 minus 14 over 4 QP. I can leave this answer like that, but if you do want to simplify it, then we would take 196 divided by 4, which I think is going to be 49, if I'm doing the math in my head correctly. Yeah, 49. So QL is 49 minus, and then 14 divided by 4 is going to be 3.5 Q price. So that is the equation of her budget line. So this intercept over here is 49, and the slope of this budget line is 3.5. And I said earlier that this 3.5 represents the relative price of popcorn. So I can confirm that as the price of popcorn is 14, the price of a lollipop is 4, 14 over 4 is the same as that, 3.5. So this is how we get the budget line, and it looks pretty much the same as looking at an isocost line. Okay, then question B asks, what does the slope of her budget line indicate? So the slope of this budget line is minus 3.5. What we say is that the magnitude or the absolute value of the slope represents the relative price of popcorn. So it represents the relative price of the product that is on the x-axis. Now, there are 2 other answers that would be just as appropriate as saying the relative price of popcorn. The relative price of something is a measure of its opportunity cost. So you could also say that the slope of this line represents the opportunity cost of a bag of popcorn. So every time she purchases a bag of popcorn, she is having to give up 3.5 lollipops. So opportunity cost would also be fine. And then the other answer that would be fine is the marginal rate of transformation. So what we know is that the slope of any feasible frontier is a marginal rate of substitution. Sorry, marginal rate of transformation. So it tells us what could the money spent on one product have been transformed into in terms of another product. So instead of me spending 14 Rand on a bag of popcorn, that 14 Rand could have been transformed into 3.5 lollipops. So Ms. Brewer asked, so when it is a negative slope, we need to indicate minus before the value. Okay, so this is why I've been very specific and written down magnitude. So yes, the slope is a negative. So this is a minus 3.5. But when we interpret the slope of this line as a relative price or an opportunity cost or an MRT, these are all equivalents, we don't mention the negative. So we actually would say that the MRT is 3.5. And we would say that the relative price of popcorn is 3.5 lollipops. And we would say the opportunity cost of popcorn is 3.5 lollipops. The negative is simply implied. A cost is negative. Okay. So to be safe, you should exclude the negative. Yes. Whenever you're interpreting relative price, opportunity cost, margin rate of transformation, you don't include the negative. You only talk about the magnitude or absolute value. Okay, then C asks, if the price of popcorn decreases to 7 Rand a bag, explain why Alyssa would then be able to consume more of both goods. So I'm a big fan of drawing graphs in order to guide answers because I think graphs just give the answer. So if we go back to the picture and we have lollipops on the y-axis and we have popcorn on the x-axis. So this is the original budget line. If we spent all the income on lollipops, we could buy 49. So that is the 196 divided by 4 gives 49. If we spent all 196 Rand on popcorn, then we could get 196 divided by 14, which is 14. So that intercept would have been 14. If the price of popcorn decreases to 7 Rand a bag, what that means is that if she spends all 196 Rand on popcorn, she would now be able to buy 28 bags of popcorn. In other words, her income in real terms, so her real income is worth 28 bags of popcorn. So her budget line will have swiveled outwards along the x-axis. So nothing happens to this intercept because the price of lollipops stays the same. So if she spent 196 Rand on lollipops, she would still only be able to buy 49 lollipops. But what you should notice is that prior to the price changing, these were all her feasible options. Now that she faces a lower price of popcorn, her feasible range expands. Feasible range expands, which means all of these options here are now possible for her. So even though only the price of popcorn is falling, she is able to buy more of both goods. So we can see that here. So this was a feasible option before. This is now a feasible option. And in this feasible option, she's actually buying more lollipops and more popcorn. Okay, so basically what we would say is that if the price of popcorn falls, her budget line swivels outwards and expands her feasible set. She is now able to consume more of both goods. And then I would probably add because she has greater purchasing power. So the fact that her feasible set has grown by this area here indicates to us that her purchasing power is greater. Okay, then question D is referring to an optimal consumption point. So what I'm going to do now is just quickly draw what we mean by the optimal consumption point. So we have Alyssa's budget line. So this is popcorn and this is lollipops. So this is her budget line. Miss Matiba asked, can we draw the graph as our answer? You can draw the graph, but you would need to write something. Okay, and the reason why you would need to write something is because it says specifically explain. Okay, so yes, you can use the graph to guide your answer, and I would be in support of that because it really helps, but you would definitely need to write something. Okay, so we have Alyssa's budget line. So this tells us what is feasible. But as I mentioned earlier, in order to make an optimal consumption choice, you need to bring what is feasible in line with what is preferred. So the way that we illustrate preferences is we use indifference curves. Now I can draw a whole range of indifference curves in this picture. In fact, there would be infinite number of indifference curves that could be drawn in one graph, and we call that a preference map. So indifference curves give us a map or view of her preferences. So what we have here is 3 indifference curves. I would say that any point on indifference curve 1 gives less utility than any point on indifference curve 2, gives less utility than any point on indifference curve 3. So higher indifference curves represent higher utility. And as a consumer, our goal is to maximize our utility. That is the goal. Okay. So if I asked you, which of these indifference curves would Alyssa want to be on? Which of those indifference curves would she prefer to be on? What answer would you give to that question? So which of the indifference curves, IC1, IC2, and IC3, would she prefer? IC3. Okay, so preferences identify what is optimal. Sorry, not what is optimal, what is best. Okay, now I can see a few of you are saying IC2, and I'm going to challenge you as to why IC3 is the most preferred. And the reason is this. If I had to ask you, what car do you want? Are you going to think about what you can afford before you answer that question? Or are you just going to know what it is that you like? Are we only allowed to prefer what we can afford? Okay, so when I ask you what you like, you're going to answer in terms of the thing that you can imagine is going to make you the happiest in the world. Yes, Ms. Brewer. So yes, most preferred is the highest satisfaction you can get. Just because you can say, okay, I want a BMW, that's what I would prefer. If I then had to ask you, well, is it actually a choice? Do you have a choice to own this car? Now you have to think about what is feasible. Okay, so IC3 is the most preferred out of all options. It just isn't feasible. So as a consumer, you are limited in your choices by what is feasible. So if I had to think about a point like A, I could never choose A. A isn't a choice. It is preferred, but it is not a choice. B is possible. I can choose B. I can afford B. Why would I not choose B? I would not choose B because this point over here, let's call it C, is also affordable, but it gets more utility. So B, yes, feasible, but isn't achieving the goal of maximum utility. So we say that a consumer reaches their optimal consumption when they spend all their budget. Okay, so this is all. So they spend all their budget. What does that mean? It means you're on your budget line. Secondly, you are on the highest attainable, so reachable indifference curve. That's the second thing. And if you're doing both of these things, your marginal rate of substitution equals your marginal rate of transformation. So Ms. Brewer asks, if they ask us what's the most preferred, we need to say that it's the highest one, but not feasible. Yes. So the most preferred option is going to be a combination that makes you the happiest, but it doesn't necessarily have to be affordable. But when it comes to an optimal choice, when you're choosing, you have to bring into account what is possible and what is preferred. So C ends up being optimal because it's affordable, it's within the feasible set, it's on the budget line, and it is optimal because B, I could also afford, but C is better than B because C is giving me more utility. Okay, this last point that MRS must be equal to MRT comes from the fact that when you are on your budget line and on the highest attainable indifference curve, we end up at a point of tangency. So this point here ends up being on the budget line and on the highest reachable indifference curve. And at this point, these two functions are tangents. And when two functions are tangents, it means their slopes are equal. The slope of the feasible frontier, the budget line, is the marginal rate of transformation. And the slope of an indifference curve is the marginal rate of substitution. So when you are at this optimal point, the slopes are equal, which means the rate at which you, as the consumer, are willing to trade these two goods is exactly equal to the rates at which you must trade the two goods. So the MRS represents the rate at which a consumer is willing to trade, so to substitute. And the MRT represents the rate at which a consumer must trade. Okay, so that's what happens when they are equal. So using all of this and going back to question D, it says, if Alyssa's optimal consumption point is 6 bags of popcorn and 28 lollipops, what is her MRS at this optimal point? So the best thing is to draw it. So we have our budget line. The optimal point must be some points of tangency. And what it's telling us is that if this is popcorn and this is lollipops, then this is 6 and this is 28. Okay, the budget line and some indifference curve. At this point, the marginal rates of substitution will be equal to the marginal rates of transformation. What is the marginal rates of transformation? We've answered that question in part B. So part B we said the slope of her budget line, which is 3.5, is the relative price opportunity cost MRT. So for question D, what answer would we give as the MRS at this optimal point? Her marginal rate of substitution at this point will be 3.5. So question 2 says, Alicia consumes only sour worms and magazines. A change in Alicia's income will change the shape of her indifference curves. Do we think this answer is true or false? If her income changes, will this affect her indifference curves? Okay, so we have a false, no, awesome. This is false. What would be affected by a change in income? So the income changing would affect what in our picture? The slope will move up in parallel. So our budget line would be shifted. So let's say this was our original budget line. If our income increased, then our budget line would shift parallel outwards. Okay, and if our income decreased, it would shift parallel inwards. So this is false. In order for this to be true, it would have to say a change in Alicia's income will shift her budget line. What would change the shape of the indifference curves? So what would change the shape of indifference curves? Any change in preferences would change the indifference curves. Okay, so yeah, prices would also affect the budget line. Okay, so the budget line is affected by income and prices. Indifference curves are affected by preferences. And I'm going to show you how that works in question 3. So I'm going to show you here how we can see that affecting indifference curves. So the MRS indicates the change in the consumer's utility when one good is substituted for another. So I'm not going to go for the answer first. I'm quickly just going to do a little bit of theory. So let's say I have this indifference curve. If I look at these 2 points here, A and B, what can I say about points A and B? How would you describe those 2 points? If I had to just ask you, what can you tell me about consumption A and consumption B? So let's say this is product Y and this is product X. And let's say that here I'm consuming 10 and here I'm consuming 3, here I'm consuming 2 and here I'm consuming 8. The person is indifferent. Okay, so at both points the consumer is equally satisfied. Awesome. Okay, so A and B give this consumer the same utility. Okay. The marginal rates of substitution measures the rate at which a consumer is willing to give up Y for more X whilst keeping utility constant. Okay, so the marginal rates of substitution tells us how much the consumer is willing to give up of one good in order to consume one more unit of another good whilst keeping their utility constant. In other words, we are staying on the same indifference curve. Okay, and that is why the MRS measures the slope of our indifference curve. Because if I had to take these words and put it into mathematical terms, what I'm saying is that the MRS measures the change in QY for a change in QX. It's how much I'm willing to change my quantity of Y when I change my quantity of X. And that's why we say the MRS is the slope of this indifference curve. So let's say we're at point A and we want to consume 1 more units of X. So let's say I want to go from 2 units of X to 3 units of X. In order to remain on my indifference curve, so to stay equally satisfied, I'm going to have to give up some Y. And let's, for argument's sake, say that in order to get 1 extra X, I am giving up 2Y. So that is my marginal rates of substitution. To get 1 extra units of X, I'm willing to give up 2 units of Y and remain on my indifference curve. If we're at point B, and now I want 1 more units of X, so I'm moving from 8 to 9, and I want to stay equally satisfied, so I want to remain on my indifference curve. What happens to the amounts of Y I'm willing to give up? That amount of Y that I'm willing to give up is smaller than what I was willing to give up at A. So if I think about what that means, why is it that I am willing to give up a lot of Y to get 1 more X when I'm at point A, than the amounts of Y I'm willing to give up to get 1 more X when I'm at B? Does anyone want to write down in the chat why it is that when I'm at A, I'm willing to give up 2Y for an extra X, but when I'm at B, I'm only willing to give up, let's say, half a unit of Y to get 1 more unit of X? Anyone see why that might be the case using the picture? And then I'll answer your question, Ms. Brewer, because I think it's a good question. Because there is diminishing marginal utility. Great. Okay. So what does that mean? That means that when I'm at A, I have a lot of Y, right? When I'm at A, I've got 10Y and 2X. So in other words, X is something I don't have a lot of, but Y is something I have a lot of. In other words, I'm very willing to give up this thing that I have a lot of in order to get something more of something I don't have a lot of. Yes. Okay. So Mandikutse says, because at A, you're consuming more of good Y than compared to B, where you have less Y. Exactly. So this is the scarcity principle. We have Y in abundance here. And so we're very willing to give up Y to get the thing that we have scarcity of. But when we're at B, now Y is scarce for us and X is no longer scarce. And so we're less willing to give up Y to get more X. Awesome. So we see that as we move along our indifference curve, the willingness for us to trade Y for X becomes smaller. So to answer your question, Ms. Brewer, about how we can put these values into this formula. So at point A here, my MRS is my change in Y over the change in X. So to get 1 more X, I'm willing to give up 2Y. So my MRS is 2. Change in Y over change in X, 2 over 1. At B, my MRS is a half. My change in X is 1, and my change in Y is a half. So my MRS lower down my indifference curve is smaller than my MRS higher up. Okay, so I really wanted to do this question so that I can explain to you where the MRS values come from. It's because as something becomes more scarce to us, we are less willing to trade it away to get something else. Okay, so just going back to the question, what would the answer to question 3 be? The MRS indicates the change in the consumer's utility when one good is substituted for another. Is this true or false? Okay, it's a bit of a tricky question to read, but let's be very careful. So the MRS indicates the change in the consumer's utility. What do we know about the MRS? The MRS is the change in our consumption, keeping our utility constant. So this answer is false. Okay, the MRS indicates how are we willing to change our consumption of these two goods whilst keeping our utility constant. Okay, great. No, it's totally fine, Ms. Mbatha. These are the types of mistakes we make in revision so that we can see how not to repeat them in a test. Yes, Mr. Zelik, you need to maintain the same level of utility. Perfect. So utility is not changing with MRS. Okay, so now let's move to question 4, which also deals with indifference curves. So question 4 says, Vuyokazi consumes only chocolate and magazines. Which of the following will lead to a change in the shape of her indifference curves? Okay, so we have a change in her preferences for either chocolates or magazines or both. So A, as Ms. Matheson says, is a true statement. Okay, so we've already said if her preferences change, that will change her indifference curves. Just to check that the rest are wrong, if there's a change in price, that would affect the budget line. So this is wrong. A change in income would affect the budget line. D, both B and C, wrong. Okay, now one last thing I want to show you with indifference curves is the follows. So this is, let's say, so let's use these two goods. Quantity of chocolate, quantity of magazines, quantity of chocolate, quantity of magazines. And let's say this is Vuyokazi and this is Alyssa. And Vuyokazi's indifference curve looks like this, and Alyssa's curve looks like this. If I asked you who prefers magazines, who would you say between Vuyokazi and Alyssa prefers magazines? Looking at those two pictures. So what we're saying with these two pictures is they have different preferences because the shape of their indifference curves are different. So who prefers magazines, Vuyokazi or Alyssa? So Ms. Matura says Vuyokazi. Plongwane, yes, I agree with you. It is Vuyokazi, and I'm going to show you why. So she's consuming one magazine. She's also consuming one magazine. If both of them want to increase their consumption of magazines by 1 and keep themselves equally satisfied, what do we notice? For Vuyokazi to get 1 extra magazine, she's willing to give up this much chocolate. For Alyssa to get 1 more magazine, how much chocolate is she willing to give up? Only that much. So what we can see based on the marginal rates of substitution is that Vuyokazi prefers magazines. She likes magazines more than does Alyssa because her willingness to give up chocolate for 1 extra magazine is larger than Alyssa's. Does that make sense? If you look at these two pictures next to each other. So we can see how the shapes of indifference curves tell us about people's preferences. And so if preferences change, the shapes of indifference curves change. Everyone happy with that? Great. Thanks, Mandikutse. So our marginal rate of substitution tells us something about this person's willingness to give something up. And that would tell us about their preferences. Okay, so now we're going to do a longer question, bringing all of these things together. So the diagram below shows the budget constraints before and after a change in prices and income, as well as an indifference curve of a consumer of good X and good Y. Okay. Question A says, calculate the value of the MRS at point A. Okay, so point A is an optimal point. And the reason why I know it's an optimal point is because at point A, budget line 1 is tangent to this indifference curve. Okay, so what must be true at point A? At point A, the marginal rates of substitution must be equal to the marginal rate of transformation. How would I be able to calculate the marginal rate of transformation at point A? What information in this picture would allow me to calculate that value? Change in Y over change in X. Yes. So I would be able to use the slope of this line to calculate the MRT, and that would then tell me what the MRS is. So what is the slope of this line? The slope of this line is going to be rise over run. So it's going to be change in Y over change in X. So it's going to be change in Y over change in X, which is 50 over 25, which is 2. Okay, so the marginal rate of substitution at point A is 2, because I know that the MRT is 2, using the slope of this budget line BL1. Okay, then B says, on BL1, if the price of good X is 4 Rand, what is the price of good Y? Okay, so if the price of good X is 4 Rand, how would we be able to find the price of good Y using the information that we have? So the MRT, which is the slope of this line, is also what? It is also the relative price of good X. So the relative price of good X is 2. And how would I calculate the relative price of X? The relative price of X would be the price of X over the price of Y. And I know that the price of X is 4. This is the thing I'm trying to find. And that must be equal to 2. So what would the price of Y need to be in order to give me an MRT, or relative price of X, of 2? The price of Y would need to be how much? R2. Okay, so the price of Y is R2. Xander asks, should it not be negative at part A? So it will not be negative, because remember, even though slopes are negative, we always write our MRS and MRT values as a magnitude. So we always write these economic terms in terms of their absolute value. So yes, the slope is -2, but we always interpret it as a positive value. Okay, so yes, technically speaking, if I calculated the slope, I would get a negative. Great. Okay, so the price of good Y is 2 Rand. Then 2 asks us for the consumer's income. So looking at the picture here, what would the consumer's income be? If I know that the price of X, so this thing costs 4 Rand, and this thing I've established now costs 2 Rand. So using the information for this budget line, because we're working with this budget line right now, what is my income based on those two prices? Ms. Matheson, 50 Rand. Yes, perfect. It is 50 Rand. So how do I see that it's 50 Rand? These two intercepts here, I would find as my income divided by the price. So if my price is 4 Rand, not 50 Rand, 100 Rand. Sorry, I got too excited there. It's 100 Rand. Okay, but thank you for taking the attempt. That was great. So I'll explain why it's 100 Rand. So if this costs 4 Rand and I can buy 25 of them with all of my income, then it must mean that 4 Rand times 25 gives me 100. Don't apologize. I was convinced by your answer. Okay, so 100 Rand would give me that 25, and then I can confirm that 100 Rand would also give me this 50, because if I spent all of 100 Rand on quantity on Y, 100 divided by 2 Rand would give me 50. So if I know what the intercepts of my budget line are, and if I know what my prices are, I can work out my income. So this 50 Rand is my income divided by the price of 2 Rand. And this 25 is also my income divided by the price of X, which is 4 Rand. Okay, so the income is 100 Rand. Is everyone happy with that answer of 100? So essentially, okay, Mr. Selick says, I think it did it a long way, but is it okay if you do 10 times 4 plus 30 times 2? That is absolutely perfect. Okay, great. Thank you for showing me that answer. So every single point on this budget line must use all income. In other words, at point A, you must be spending all of your income. So point A must be, okay, so I'm just going to rather write it as Y. So at point A, whatever you have as income must be equal to what you spend on Y plus what you spend on X. And if I calculate that, I get 60 plus 40, and that's 100 Rand. Perfect. Okay, so you could either use this point here, or you could use the intercepts, and it would get you to the same answer. Thanks for sharing that, Mr. Selick. Okay, then C, on BL2, what is the relative price of good Y? So now we're looking at the other budget line, and we're looking for the relative price of good Y. So if we look at budget line 2, that's this line over here. Okay. Now, how can we identify the relative price of good Y? So what we can see is that at this intercept here, whatever I have, I'm getting 50Y spending all my money. And over here, I'm getting 50X spending all my money. And here I'm getting 25Y spending all my money. What does that tell me about the relative cost of Y compared to X? Okay, so these two intercepts tell me if I spend all my income, this is how much X I could buy, and this is how much Y I could buy. So if my income gets me 25 units of Y, but that same income gets me 50 units of X, what does that tell me about the price of Y relative to the price of X? Think through it a little bit. Maybe I'll put it into different terms. With the same income, I can afford twice as much X as I can Y. Okay, exactly. So 1 to 2. So for the same income, I can get twice as much X as I can Y. So the price of Y must be equivalent to 2X. Perfect. So the relative price of good Y is 2X. Okay, let's go on to question 6. So now we're moving into the model that is shown by this picture here. So we're going to look at the model that deals with the feasible frontier and the production function. So question 6 says, Alana chooses how many hours to spend studying for a test. If the final grade she can achieve is given by a concave production function, this implies that the marginal product of each hour she uses to study what as the number of hours of study what. Okay, so if I had to draw a concave production function, so this is her grade and this is her hours of study. A concave production function will look like this. Okay, so this is concave. A convex production function would look like that. So looking at this picture here, what would happen to the marginal product of each hour of study if the number of hours of study increase? So what does the marginal product represent? The marginal product is the change in the output, the total product, when hours of study change. So let's say she's currently studying this many hours. So let's say 4 hours. And if she studies 5 hours, her grade goes up by this much. If she had to study 1 more hour, so a marginal hour, her grade would still go up, but it would go up by less than the previous hour of study increased her grade. And so the answer to this question would be the marginal product of each hour she uses to study decreases as the number of hours of study increase. So the answer is D. So the marginal product of a concave production function is diminishing. This represents diminishing marginal products. For each extra hour used for studying, the additional grade, so the change in the grade would get smaller. Okay. Everyone happy with question 6? Okay. Question 7. So the figure below shows the feasible frontier and indifference curve of a high school student who faces a trade-off between free time and school marks. Okay, so this is the feasible frontier and an indifference curve. At point A, the student is not in equilibrium because, and he could increase his utility by what? Okay, so let's look at point A. What is the slope of the indifference curve? How do we measure the slope of an indifference curve? We use the marginal rates of substitution. The slope of a feasible frontier, we measure using the MRT. Okay. So if we look at point A here, which is bigger? Is the MRS bigger or is the MRT bigger at point A? So which is bigger? So that's the indifference curve. So this is the slope of the indifference curve. This is the feasible frontier. So that's what the slope of the feasible frontier looks like. So which one looks steeper? The indifference curve. So the MRS exceeds the MRT. Okay, that slope is flatter than the slope. So the MRT is smaller than the MRS. So if I go to the question, I can immediately eliminate A because the MRT is not greater than the MRS. I can eliminate B because MRT is not greater than the MRS. So now I have to choose between C and D. So is this person going to increase their utility by studying more or spending more time not studying? So if we look at this picture here, where would an optimal point exist? So if this is the shape of the indifference curves, then I could argue that an optimal point would be somewhere like here. Okay. So looking at A versus this point here, would higher utility be achieved by studying more or studying less? So if we compare A to here, what do you notice? This is the amount they study. This is the amount of free time here. This is the amount of free time here. Yes. So they would get more utility by increasing their free time. So the answer is D. Now we can think about this intuitively using these two concepts. So what does the MRS represent? The MRS represents how much I'm willing to give up. This represents how much I have to give up. So what this says is that at point A, I am more willing to give up grades for more free time than the rate at which I have to give up grades for more free time. That would mean that I will increase my free time because I actually prefer free time. I'm willing to get rid of grades so that I can study less, so that I can enjoy more free time. So the fact that the MRS is greater than the MRT tells me that they are willing to give up this thing, the marks, in order to get more of this. Okay, so the answer to this question is D. Because the MRT is less than the MRS, this individual will increase their free time in order to increase their utility. Does that make sense? Okay, I see your hands up. Question 8. Carlissa learns a new study technique that allows her to achieve a higher mark for every given number of hours she spends studying. This is shown by the outward shift of her feasible frontier in the figure below. So this is her new feasible frontier. I'll call it feasible frontier 2. And this is her original one, feasible frontier 1. So there has been an expansion of her feasible set. So because she is able to be more effective in her studying, it means that these are now feasible options. Okay. So what we need to now figure out is whether this statement is true or false based on the picture. So it says, based on this information, we can say with certainty, that's a very important word, we can say with certainty that Carlissa will derive more utility from option C than she would from option D. Is that true or false? Can we say with certainty that she would be happier at C than D? False. Okay? Why is it false? Why can we not say with certainty whether or not C is more preferred than D? What would we need to know in order to figure that out? Okay, so they're on the same feasible frontier, which means she's maximizing the use of her study time. So she's achieving the maximum possible grade for the amount of time she's studying. So that's what that means. But why does that not tell us anything about whether C is more preferred than D? What do we need to know in order to figure out utility? We'd need to know her indifference curves. Exactly. Are there any indifference curves in this picture? No. There are no indifference curves. So because we have no indifference curves, we cannot possibly know which of these gives her more utility. Okay, so we don't have the indifference curves. Now, I'm going to ask you a different question. Can we say with certainty, so can we say with certainty that Carlissa derives more utility from C than from B? Can we say with certainty that she gets more utility from option C than option B? Yes. Why can we say that? So we know we don't have her indifference curves, right? So how can we say that C makes her happier than at B? Because if we compare B and C, she's getting the same amount of free time, but she's getting a higher grade for that free time. Exactly. So C will certainly, most definitely derive her more utility than B, because C represents, what's another term we can give if we compare B to C? C is a Pareto improvement over B. Okay? If we compare B to C, she is able to get more grades, but not having to sacrifice any of her free time. Okay, so we would also say that B is inefficient. And we can also argue that B is inefficient because it lies inside her feasible frontier. If we're inside our feasible frontier, we are not getting the full value for the free time or for the hours of study. Okay, so we can definitely with certainty say that C is preferred to B, but we cannot with certainty say whether C is preferred to D. Great. Okay, I'm going to move now to the work consumption model. So I'm now going to move to this picture in the middle. So we're going to do some theory from that section. So we get told that a worker faces the following consumption constraints, where T is hours of free time per day and C is consumption. The worker is paid in rands. Now, what I want to show you is that this comes directly from this picture I've drawn here. So what I said earlier is that consumption at most will be however many hours you work times the wage rates that you can earn. Okay, so we would say that your consumption would be your wage rate times your hours of work. How many hours do you have in a day? You have 24 hours in a day. And according to this theory, you can split that time between work and free time. So if I rearrange this formula so that H is the subject, what would H be equal to? H would be equal to 24 minus T. So I can rewrite that as C equals WH is equal to W 24 minus T. This is the same as that. Okay, so consumption is always the wage rate per hour times 24 minus T. So if you know that information now, what is the wage rate that this person is paid per hour? Based on that consumption constraint, what is the wage rate that they are paid per hour? 10. Great. Okay, so that's where that constraint comes from. Let's assume that this worker can work for a maximum of 15 hours a day. What is the worker's maximum possible daily consumption? So at most, they can work 15 hours a day. We've just established that their wage rate is 10 Rand. So what is the maximum consumption per day? 150 Rand. Great. So that we would find as 15 times that 10 Rand, which is the wage rate. So if I had to plot this worker's consumption constraint, so if I have consumption on the y-axis and free time on the x-axis, the budget constraint would have 24 as the intercept there, and that intercept would be 150. What would this value at the origin be if at most you can work 15 hours a day? So if you're working 15 hours a day at most, what is the minimum free time in a day? So the maximum free time is 24. What would the minimum free time be? 9. Perfect. Okay, so that's how the budget constraint, the consumption constraint would look using this information. Now assume that an anonymous benefactor pays this worker 100 Rand every day, irrespective of the hours worked. What is the opportunity cost of 1 hour of free time? Okay, so what do we mean by the opportunity cost of something? We mean this is what you have to give up if you consume this thing. So if you consume an hour of free time, what do you give up? So if you consume 1 hour of free time, you're going to give up 10 Rand, the wage that you could have earned in that hour. The wage is going to increase by 5 Rand for every hour worked, and he will still receive the 100 Rand from the benefactor. So what would the equation for the new consumption constraint be? So Ms. Matheson, you already gave this answer, so you can type it again if you want. So what would the equation of this new consumption constraint be if they get the 100 Rand, irrespective of how much they work, but now their wage is 5 Rand higher? So the consumption constraint would be similar to this, but now this value of 10 would be 15. So it would be 15, 24 minus T plus 100. So this would be the new consumption constraint. Perfect. Okay, what is the substitution effect of this wage change on free time? Explain your answer. No calculations are required. So what I'm going to do is I'm actually going to come back to this when we do substitution income effects. I'm first going to do a few more questions looking specifically at this concept of the wage rate as the opportunity cost, because I just want to make sure that that concept is solidified, and then I'll come back to this. So we have this question, question 10, that says, during the ends of year holidays, you find work selling ice creams for a shop next to the beach. The company tells you that you'll be paid per hour and your hours are flexible. So you can choose how much you want to work. So here we have the budget constraints and some indifference curves. Now, looking at this picture here, what would the hourly wage rate be that this company is paying you? So Ms. Matheson says 15 Rand. Anyone else have a different answer or agree with that? We can then maybe go into how you calculated that. So what we can see here from this budget constraint is that the minimum amount of time you're going to spend in free time is 8, which means your maximum hours of work is 16. So this 240 represents how much you earn when you work 16 hours exactly. So it's going to be 240 divided by 16, and that gives us 15 Rand. So the answer is C. Okay. What do you think is a common mistake that people might make with this question? A common mistake is that they would say 240 divided by 24. So they would think this is 0. Can you please explain again where you got the 16 hours? So how I got the 16 hours is, this is free time on my x-axis. 24 must be equal to hours of work plus hours of free time. So hours of work must be 24 minus t. So if my t is 8, then I find 16. Ms. Machabe says some would divide by 8. Yes, some people might divide by 8 instead of 16. Exactly. So there are a few mistakes that could be made with this question, but I feel that now that we've gone through it and I've highlighted what that means, this will definitely not be an issue on Friday. Okay, so Ms. Ngwende, are you happy now with where the 16 and the 15 Rand comes from? We'll go to another question, which deals with the same theory. So Jim receives a wage of 20 Rand per hour. Dwight receives a wage of 15 Rand per hour. To maximize utility, Jim works 35 hours and Dwight works 42 hours. The opportunity cost of an additional hour of free time is higher for Dwight than it is for Jim. Is this true or false? So Jim gets a wage of 20, Dwight gets a wage of 15. So is the opportunity cost of free time higher for Dwight than it is for Jim? True or false? Mr. Selleck says false. Yes, false. Okay. The opportunity cost of an hour of free time is the wage rate. So if Dwight takes an hour of free time, he gives up 15 Rand. If Jim takes an hour of free time, he gives up 20 Rand. So whose opportunity cost of free time is higher? Jim. So this is false. Okay, so Dwight faces a lower opportunity cost of free time than Jim because his wage rate is lower. Okay, question 12. The figure below indicates the feasible set of a student's final grade and hours of free time per day. Based on this information, we can say that the student's choice between A or B depends on their preferences. It's not feasible to do B, yes. So what word here is telling us this answer is false? The word is choice. Choice depends on what is possible or feasible and what is preferred. And so looking at this picture, is B a choice? B is not a choice. Okay, so for this student, B could never be chosen for the moment, right? I mean, if they had an expansion of their feasible frontier, B could be possible. So because B cannot be chosen, this is false. Okay, so it's a bit of a tricky question. If the question had said, based on this information, we can say that B is preferred to A, then it would have been true. By all means, B is preferred to A. But can B be chosen? No. Okay, so question 13 says, the graph below indicates the feasible frontier of James, who produces and consumes nachos, as well as his indifference curves. Which point on the graph is James' most preferred point? Explain your answer. So which point on this graph is the most preferred? E. Great. Why is it the most preferred? So E is the most preferred point because it is on the highest indifference curve. Okay, so E is the option of all options that James would like. Would James choose E? No. So why can't James choose E? He can't choose E because E is not feasible. Great. Okay, what is James's opportunity cost of an hour of free time at point A? So if we look at point A, he has 8 hours of free time and he's consuming 18 nachos. If he consumes 1 more hour of free time, he has to give up 2 nachos. So what is the opportunity cost of that extra hour of free time at point A? At point A, if he chooses 1 more hour of free time, he gives up 2 nachos. So that is the opportunity cost, 2 nachos. Okay. Now for this answer, because we're talking about opportunity cost, whenever you talk about opportunity cost, relative price, MRS, MRT, it is good practice to put it in terms of the thing that is being traded. Okay, so when it comes to an A2 and A3, if you just write 2, the marker will most likely be quite kind and give you the full 1 mark. But I want to ask you to be as perfect as possible and to write 2 nachos. Okay, so just always put these concepts in terms of something, because it is something you're having to give up. Okay, just to make sure you're covering all your bases. Then C asks, what is James's optimal decision point? So looking at this picture, what is his optimal decision? C. Okay, so C is the optimal decision. How do I know that's optimal? I know it's optimal because he is on his feasible frontier. So he's using all his resources. He's reaching his highest attainable indifference curve. So the highest indifference curve that is possible. And at this point, it's tangent MRS equals MRT. And I see all that stuff coming up in the chat. Awesome. Great. Okay, let's now move on to the dreaded income and substitution effect. But I'm going to hopefully make this really, really clear and understandable. Okay, so the way I like to approach the income and substitution effect is I first like to reason through it before I go to any of the graphs. So the way I reason through the income and substitution effect is as follows. So we have 2 goods. So let's use question 14. We have coffee and bread. Okay, so we have coffee and bread. And then we have a price for coffee and bread. Okay, so they don't give us any information here, but that's fine. So we have some price for coffee and bread. So let me just write it down like that. Then we have a relative price. Okay, so in this question, it tells us that the price of coffee increases, ceteris paribus. Now, what does that ceteris paribus mean? That ceteris paribus means that the price of bread doesn't change and this consumer's income doesn't change. So I'm just using this bar to represent doesn't change. But the price of coffee goes up. Okay, so this is what is happening. If the price of coffee goes up, what happens to the relative price of coffee if its money price increases? So if coffee becomes more expensive, what happens to its relative price? So remember, a relative price is the price of that thing divided by the price of the other good. It increases, yes. So if the price of coffee goes up, if this is the relative price of coffee, then it becomes relatively more expensive. What happens to the relative price of bread if the price of coffee goes up? So what happens to the relative price of bread if the price of coffee goes up? Okay, so this is how we calculate the relative price of coffee. How would I calculate the relative price of bread? It would be the price of bread over the price of coffee. So if this thing doesn't change, but this thing gets bigger, the relative price of bread goes down. Great. Okay, so if the price of coffee goes up, coffee becomes relatively more expensive, bread becomes relatively cheaper. The substitution effect has to do with relative price. Okay, what we say with the substitution effect is that the consumer substitutes towards the relatively cheaper good and away from the relatively more expensive good. So that's what the substitution effect is identifying. Okay, so the substitution effect means you change the way that you substitute these two products by choosing more of the relatively cheaper thing and less of the relatively more expensive thing. And the reason why you are making this change is in order to keep your utility the same. So the substitution effect is a long and indifference curve. Okay, so if coffee becomes relatively more expensive and bread becomes relatively cheaper, will the substitution effect for coffee be positive or negative? So will the substitution effect for coffee be positive or negative if it is now relatively more expensive? Yes, it will be negative. What will the substitution effect for bread be? Will it be positive or negative? Okay, so the substitution effect for coffee will be negative, and the substitution effect for bread will be positive. Okay, so this is saying the consumer, in order to remain on an indifference curve, will substitute away from the more expensive thing towards the thing that is now cheaper. So how do I know if it's negative or positive? So what do I mean by negative substitution effects? Negative means you buy less of it. So negative is saying less. Positive is saying more. So the substitution effect says you buy less of the thing that is now relatively more expensive. That's why it's negative. And you buy more of the thing that is now relatively cheaper, which is why the substitution effect is positive. Does that make sense? So the negative and the positive identify your decision to buy more or less of it. Okay. Cool. So this is the substitution effect. How do we identify the income effect? So the substitution effect has to do with relative prices. The income effect has to do with whether a good is inferior or normal. So someone answered this question in the chat. So someone asked, what is the difference between a normal good and an inferior good? So the answer that was given in the chat is that normal goods, for normal goods, consumption increases when income increases, and inferior goods, consumption decreases when income increases. Okay, so I'm going to change that slightly. So normal goods, we consume more of when we have more income, and inferior goods, we consume less of when we have more income. So think about inferior goods this way. Once you have more income, this thing is no longer good enough for you. It's inferior. It's only something that you consume when you don't have a lot of income. Okay. So an inferior good is if income goes up, the quantity you buy goes down. A normal good is if your income goes up, the quantity you buy goes up. Okay. So that's how we distinguish between the two. Now, thinking back to earlier, when we were looking at lollipops and popcorn, so I'm just looking for the picture, we said that if the price of popcorn goes down, it has this increased effect on what is feasible for us. So we get greater purchasing power. So when a price goes down, we have more purchasing power. It's like we have more income. If in this situation, the price of coffee is going up, what does that mean for our purchasing power if the price of one of the products that we are purchasing increases? So what happens to purchasing power because of this higher price? Our purchasing power decreases. So higher prices make us feel like we have less income. We become relatively poorer. Our real income is less. Okay? So thinking about it like this, if I have less purchasing power, I'm going to buy fewer normal goods, because remember, if income goes up, quantity goes up if it's normal, which means if income goes down, quantity goes down if it's normal. If my purchasing power goes down, I'm going to buy more inferior goods, because if income goes down, my quantity of inferior goods goes up. So in the question, it tells us that coffee is normal, but bread is inferior. Okay, so coffee is normal, bread is inferior. So looking at this information in combination with the purchasing power, if I have less purchasing power and coffee is normal, is my income effect for coffee going to be positive or negative? So if my purchasing power goes down, and coffee is a normal good, is my income effect going to be positive or negative? It's going to be negative. Great. Okay, so the income effect on coffee will be negative. I will buy less of it. What would the income effect for bread be if my purchasing power goes down and bread is inferior? So if bread is inferior, it's going to be positive. Okay, so what we can conclude is that coffee has a negative substitution effect and it has a negative income effect. So how much coffee do you think I'm going to be buying once the price goes up? I'm definitely going to be buying less coffee because both the substitution effect and the income effect are negative. So after this price change, I'm definitely buying less coffee. Am I going to be buying more or less bread if the price of coffee goes up? I'm definitely buying more bread because I can see that if the price of coffee goes up, I'm going to substitute towards bread. My income effect is going to be positive because bread is inferior. So I'm definitely buying more bread. So the effect of coffee becoming more expensive is that I buy less coffee and I buy more bread. So in terms of this question, it says the substitution effect on the consumption of bread is, and we established that bread will have a positive substitution effect. So this is incorrect and this is incorrect. So we're choosing between A and B. So the substitution effect on the consumption of bread is positive, and the income effect on bread is also positive. So the answer is D, positive and positive. No, it's fine. Don't worry. Happens to the best of us. I've made mistakes myself. Okay, now we're going to go to question 15, which uses the same theory. So we're going to apply the same sort of thought process to question 15. So here we get told that there's a good Y and a good X. And the price of good Y decreases while the price of good X and the person's income remain the same. If the person's consumption of X remains unchanged after the decrease in the price of Y, this means what? Okay, so I'm going to go through this step by step. So we have good Y and good X. We get told that the price of Y goes down and the price of X stays the same, and the income is also staying the same. What happens to the relative price of Y if the price of Y decreases? So what happens to the relative price of Y if the price of Y decreases? It becomes relatively cheaper. Great. What happens to the relative price of X if the price of Y goes down? X is going to become relatively more expensive. Okay, so the effect of the price of Y going down is that Y becomes relatively cheaper and X becomes relatively more expensive. How are my substitution effects going to look then? Okay, so if Y is now relatively cheaper and X is relatively more expensive, is my substitution effect for Y going to be positive or negative? And is my substitution effect for X going to be positive or negative? So my substitution effect for Y is going to be positive, and the substitution effect for X is going to be negative. Great. Okay, now let's go back to the information. It says the person's consumption of X remains unchanged after the decrease in the price of Y. Okay, so we know that there's also going to be an income effect. And if we add our substitution and our income effect, we get our overall price effect. So what we're saying is that the overall effect on X is 0. So the income effect plus the substitution effect must give me a 0 change. So is the income effect for X going to be negative or positive for this price effect to be 0? So is the income effect for X going to be negative or positive? It's going to be positive. If I add a negative to a positive, and that negative and that positive are the same size, I'll get a 0. So I know for sure that the income effect for X is positive. Okay, so now we can look at the options A, B, C, and D. So A says, this means that the income and substitution effects are not applicable in this instance. That is completely wrong. Okay, whenever a price changes, there will always be an income and substitution effect. B says the income and substitution effects on the consumption of X are 0. This is also wrong. Okay, if Y is now less expensive, it will automatically make X relatively more, sorry, if Y is cheaper, it will automatically make X relatively more expensive. And so there will definitely be a substitution effect. It doesn't mean that these two things will be 0. It just means that they balance out. C says the increase in the consumption of X caused by the income effect is countered exactly by the decrease in the consumption of X caused by the substitution effect. That is correct. And then D says the income and substitution effects work in the same direction. So this is wrong because what we've seen is that in order for this to be 0, these have to be opposite directions. So D is wrong. Okay, so the answer to this question is C. Does this framework help you to decipher what goes on with an income and a substitution effect? So this is how I like to approach it, but now I'm going to show you how it looks in a graph. Everyone, good for me to go on to question 16. Okay, so now we've seen how this works in theory. Let's now put it in a picture. So you are working as an intern during the summer holidays and currently optimize your labor-leisure decision at point A. You only have labor income with which to spend on consumption. So here's the picture. So we're currently at A, which means this person is currently on this budget line. Okay, so they are on this budget line and they are attaining this level of utility. Question A then asks, what is your current hourly wage rate? So we should definitely know how to do this by now. So what is the wage rate given the values in this picture? Yeah, 2,400 divided by 16. So that gives 150 rands. Awesome. Okay, so the hourly wage rate is 150 rands. Your employer is impressed with the quality of your work and decides to increase your hourly wage to 200. This takes you to a new optimal point B. So now we're at point B. And we can see that because of the higher wage rate, the budget line swivels outwards. What would we call the movement from A to B? So moving from A to B, which is moving from one optimal point to another optimal point, we call this the price, or in this case, the wage effect. So this is the overall effect of a change in a price. This effect from A to B can be broken into two parts. So we can break up that movement from A to B into a substitution effect and an income effect. Okay, so how do we identify the income effect? We identify the income effect by going to our original budget line and we move it parallel outwards until it reaches our higher indifference curve. So what this movement represents is what kind of income increase would give us the same utility as our new optimal point. So this parallel movement like this is the income effect. So this dashed line over here, that is what we call a hypothetical budget line. It's kind of saying, hypothetically, we could have reached this level of utility, not by a wage increase, but by getting more income. So that's what this move represents. So the movement from A to C is the income effect. When we're at C, what we now find is that actually this lies beyond our budget line, but also because the wage rate has changed, this slope no longer represents the relative price of free time. This slope now represents the relative price of free time. And so our substitution effect says free time has become more expensive. Our wage rate was 150 and now it's 200. So free time is more expensive. So what does the substitution effect say? The substitution effect says substitute away from the thing that is now more expensive. So free time is now more expensive. So we substitute away from free time towards consumption. So that movement from C to B is our substitution effect. So this is how we can see that description of the income and substitution effect in a graph. A to C is the income effect. The reason why the income effect for leisure is positive when we have a higher wage rate is because when we get paid more, we have more income. We can earn more. Our earnings power has gone up. And so we would buy more free time. Free time is normal. It's something we want more of when we have more income. Consumption is also normal. So consumption is just everything else we consume. So the income effect for leisure is positive and the income effect for consumption is positive. So that's the move from A to C. The substitution effect for free time is negative because free time is now more expensive. We substitute away from it. So we're substituting along our indifference curve away from C towards B. So the substitution effect for free time is negative, but the substitution effect for consumption is positive. So that's how we find the substitution income effects in the picture. So if we look at question B, it asks us, what are the income and substitution effects on your free time? Provide economic reasoning for the directions of these effects. So if I look at the picture, my income effect on free time, so the income effect on free time is plus 1 hour. I'm moving from 16 to 17 hours of free time. And the reason why this is positive is because free time is a normal good, which means I consume more of it when my earnings increase. So the income effect is positive because it is a normal good. The substitution effect on free time is -3. It's from 17 hours to 14 hours. And the reason why it is negative because the opportunity cost of free time has increased. So because the wage rate has gone up, free time is now relatively more expensive, which is why I substitute away from it. So there are a few questions in the chat. Can you explain again the movement of substitution effect from C to B? Okay, so if I look at C, what C represents is a tangency between this hypothetical budget line and my new higher indifference curve. In other words, at C, the MRS equals the original MRT. So it has the same slope as my old budget line. So this is using the old MRT. But what we know is that the wage rate has actually changed. So the marginal rate of transformation is no longer represented by this slope. It's represented by that slope, which is why we substitute away from C towards B, because we need to make sure that our MRS is now equal to our new marginal rate of transformation. So this represents the new wage rate. Okay, so C to B is showing that because the MRT is now changed, my wage rate is no longer this low, my wage rate is increased, which is why I substitute away from free time towards consumption. That's what that movement represents. I'll show you the answer to B now. I just want to see the other question. How do we know which one dominates the other? For example, income effect dominates the substitution effect. Okay, so look at this picture here. The income effect is +1. The substitution effect is -3. So what is the overall price effect? The overall price effect is the substitution effect plus the income effect. The substitution effect is -3. The income effect is +1. So the overall effect is -2. And I can see that because originally I was working 8 hours a day, so I had 16 hours of free time, but now I have only 14 hours of free time. So I've lost 2 hours of free time. I've chosen to reduce my free time by -2. So in that case, which effect dominated? If my overall effect is -2, my substitution effect was negative and my income effect was positive, it must mean that my substitution effect dominated the income effect because the overall effect is negative. Does that make sense, Ms. Matiba? And then I'm just going to show the answer to part B again. Okay, great. So the theory here is exactly the same as this reasoning that I wrote down over here. Exactly the same reasoning, but it's just represented graphically. I think that was the last question. Yeah. Will this video be available on Sunlearn for revision again? Yes, it will. So I will upload this video onto Sunlearn. I'm just going to edit it a little bit and then I will upload it as soon as possible. Yeah. So that was everything that I planned to do. And I think we tackled everything of Unit 3. Hopefully you all feel a lot more prepared. Oh, question 9. Thanks, Nikki. Yeah, let's do it quickly. So, right. Question 9, part D. What is the substitution effect of this wage change on free time? Explain your answer. No calculations are required. Okay. So we said that the wage rate went up by 5 Rand. So the wage rate was 10 Rand. Now the wage rate is 15 Rand. So what would the substitution effect be on free time if the wage rate goes up? So what would the substitution effect on free time be if the wage rate goes up? The substitution effect would be negative. And the reason why is because free time is now more expensive. Yes, so the substitution effect would be negative on free time because the opportunity cost of free time is higher. Perfect.